Welcome to this explainer. We are about to dive headfirst into the invisible but absolutely fascinating world of chemical reactions. Today, we aren't just staring at abstract formulas on a page, we're going to unlock the fundamental chemistry of acids and bases that literally makes our entire world work. Let's get right into it. Now, you might be wondering, what on earth do a bubbling stomach, a rising cake, and a freshly treated crop field all have in common, right? It kind of sounds like the setup to a weird joke, but I promise you, it's not. The connection between all of these seemingly random things is entirely chemical. To solve this mystery, we'll quickly cover the chemistry of everyday life, the reactive world of acids, the reactive world of bases, acids and bases around us, and wrap up with a quick revision and a challenge. All right, part 1, chemistry of everyday life, real-world reactions. So the absolutely crucial thing to remember here is that acids and bases are incredibly active substances. They don't just sit there doing nothing. They love to interact. Think of them as the invisible engines driving essential reactions when we digest our food, when we bake in our kitchens, and when farmers manage their soil to grow our crops. They are constantly reacting with metals, carbonates, bicarbonates, and, as we'll see, even with each other. Moving right along to section 2, the reactive world of acids, bubbles, fizz, and neutralization. Picture this. You drop a zinc strip into a beaker of hydrochloric acid. Almost immediately, you're going to see bubbles forming all over it. This perfectly illustrates a pretty universal 3-step reaction. You add a metal to an acid, it produces a salt, and it releases hydrogen gas. Every single time. Looking at the actual chemistry here, the zinc reacts directly with the hydrochloric acid to form zinc chloride, which is our salt, and it sets hydrogen gas totally free. And it's not just zinc. Acids react in a really similar way with other active metals like magnesium and iron too. This is exactly what makes acids so incredibly corrosive. Now, here is a really fun sensory detail for you. How do scientists actually know those invisible bubbles are hydrogen? Well, they test for it. If you bring a tiny flame near that released gas, it burns with this very distinct, super satisfying pop sound. It's a classic, foolproof way to identify hydrogen gas in the lab. Okay, so what happens if we change up the ingredients a bit? If you add an acid to a metal carbonate, the whole reaction changes. You get this immediate, really vigorous fizzing. Why? Because instead of hydrogen, this reaction rapidly produces carbon dioxide gas alongside a salt and some water. Whether it's a metal carbonate, like chalk mixing with vinegar, or a metal bicarbonate, like baking soda reacting with acidic ingredients in your cake batter, the result is exactly the same. Carbon dioxide is released. Actually, those trapped bubbles of CO2 are exactly what make your baked cakes and bread so delightfully soft and fluffy. It's literally a chemistry experiment in your oven. But, it's not all delicious baking and fun science experiments. This exact same chemical reaction has a bit of a darker side. Beautiful, ancient marble monuments are mostly made of calcium carbonate. So when acidic rain falls on them, it kicks off this exact reaction, slowly eating away at the marble and permanently damaging their historic surfaces. It's a real problem. So who's the secret agent causing all this chemical chaos? It's the hydrogen ion, or H+. But here is the crucial catch. An acid can only release these ions and show its true acidic nature when it's dissolved in water. Without water to help it out, it's actually completely harmless. Water is the key that unlocks the acid. All right, section 3, the reactive world of bases, the perfect counterattack. When acids and bases collide, it is basically like two opposing forces meeting on a battlefield. They undergo this really famous process called neutralization. But instead of a chaotic explosion, they effectively just cancel each other out. They neutralize, leaving behind nothing more than a simple salt and water. This right here is one of the most important chemical equations in existence. Hydrochloric acid reacts with sodium hydroxide. Together, these two incredibly potent active chemicals neutralize each other entirely to create sodium chloride, which is just common table salt, and water. It's kind of wild to think about, right? Two dangerous chemicals making salt water. And this neutralization stuff isn't just a neat theory for textbooks. It's incredibly useful in our daily lives. Like when you suffer from heartburn or acidity, you pop an antacid. Well, that antacid is just a base working to neutralize the excess acid in your stomach. In the exact same way, farmers save their crops by adding basic lime to soil that's gotten way too acidic. It restores the perfect balance for plants to grow. Bases also have some really unique tricks of their own, especially when they react with acidic oxides. Try this. If you take a straw and blow air from your lungs into clear lime water, the carbon dioxide from your breath reacts directly with the base. Instantly, a white precipitate of calcium carbonate forms, turning that clear liquid into a cloudy, milky white color. It's a great visual trick. Now, the secret agent for bases is the hydroxide ion, or OH-. When dissolved in water, these are the exact ions responsible for a base's bitter taste and that weird slippery feel they have. And importantly, these free-floating ions also allow basic solutions to easily conduct electricity, which is used all the time in industrial processes. It really is a microscopic war of opposites. Acids produce H+ ions, taste sour, and corrode most metals. Bases, on the other hand, release OH- ions, taste bitter, feel slippery, and while they don't react with all metals, strong bases will definitely react with specific ones, like zinc or aluminum, to release hydrogen gas. They are the absolute perfect counterweights to each other. Okay, Section 4. Acids and bases around us. The chemistry in your home. You are actually handling these chemicals every single day. You eat mild acids constantly, like citric acid in lemons or lactic acid in curd. Then you rely on bases, like soap and detergent, to wash up. Even your everyday toothpaste is a base. It's designed specifically to neutralize the harmful acids produced by bacteria in your mouth. Let's wrap things up with Section 5. Quick revision and challenge. Let's summarize. Be sure to remember these core takeaways. Acids are superactive substances that release hydrogen gas when mixed with metals and carbon dioxide when mixed with carbonates. The entire reason they act this way is because of the hydrogen ions they release in water. Bases mirror them perfectly by releasing hydroxide ions. And when those two opposing forces meet, they neutralize each other completely to form simple salt and water. Before we go, I want to leave you with a quick final challenge to ponder. Based on the secret chemical agents we revealed today, and thinking about the foods you eat, the products you use, or just the environment around you, where else do you see neutralization happening in your own life? Keep your eyes open, because chemistry is literally happening everywhere. Thanks so much for joining me for this explainer, and keep staying curious.